Combined heat and power is a name that just refers to distributed generation, and all that is creating electricity at the physical point of your business. So if you're a large industrial commercial facility, combined heat and power is basically just having like a generator that creates electricity for your company right there on site, and you have that. Now there's a technology called Bloom Energy Box. They also call it the Bloom Energy Server, and Google and Amazon use it, and they use a state-of-the-art technology that's 2 to 3 times more efficient than most other distributed generation systems. And that's why we have this up on the screen right now, because it's one of the top tier ways to set up a distributed generation system. And what's neat about these things is that they comprise a very large percentage of the overall generation capacity in Texas. The Texas CHP capacity additions, they started out in 1945 and just hit 2,000 units around 1950. Then there was another spurt in 1980. They went up to 4,000 units, and then by 1995 there was over 8,000 of these distributed generation systems that were in operation. And since 2002, it's just skyrocketed. The natural gas kilowatts that are produced, the generation capacity in kilowatts that are produced by a combined cycle system is 12,314,000. And just to put that in perspective, the overall total of all CHP fleet systems is 16 million. And what I'm going over here is all the different kinds of distributed generation systems that are in commercial facilities. Of the 16 million kilowatts available through generating capacity, 12 million of that is from natural gas. And the reason for that is because natural gas is the most efficient method of generating electricity via a distributed generation system. And here's a fuel source breakdown. As you can see, natural gas is the blue, and the light blue is wind. And natural gas is a large percentage, but not the biggest. Coal is the biggest, and the reason for that is coal is very, very cheap, and we have a lot of coal-powered power plants. But natural gas could very easily overtake that. And as far as CHP systems, as you can see, that's the purple, and the purple is getting close to being equal to the non-CHP natural gas generation systems. And these are the generation facilities that generate electricity for all homes and small businesses throughout Texas. And so we're saying that CHP systems are getting close to equaling that. Now, Texas electricity generators, the average heat rate, and heat rate is the amount of energy it takes to convert natural gas to electricity. Natural gas, non-CHP, you can see is almost approaching 9,000, but natural gas CHP is at 7,000. And this just means that distributed generation systems at this on-site at the facility are much more efficient than natural gas generation facilities that send power throughout power lines to homes and small businesses. Now take a look at this. Texas natural gas usage is going to be 500 billion cubic feet by combined heat and power distributed generation systems. This is 200 billion more cubic feet than traditional electric utilities. Now the Texas electricity load is expected to increase to 500 million megawatt hours by 2025. So the goal here is to get these distributed generation systems, or CHPs, to get them up to 35% of the total generation get it up to 35% of total generation among all other sources. So if you look at this graph right here, it's showing all the different sources: other, wind, nuclear, coal, natural gas, and CHP. CHP is the blue one at the bottom. It's relatively small compared to the others. Although it's beating other, wind, and nuclear, it's still fairly small. Now this is showing it as a percentage, and you can see again it's fairly small compared to the other ones. Now that can be expected when you're comparing it to wind, although wind is increasing by like 6% per year. So wind's going to be a very big contributing factor in Texas eventually. Now, what kind of factor is CHP going to be? Well, with the goal of 35% of natural gas CHP by 2025, look at that blue one at the bottom. It's bigger than all the rest, and this is in megawatt hours. It's going to be producing on-site distributed generation systems are going to be producing more energy than any other source, and this is a percentage of the total here. And as you can see again, it's going to be the primary source of electricity in Texas compared to all the other generation facilities out there. It's going to be wind, nuclear, coal. It's natural gas, on-site electricity generation. Okay, this chart is just showing you how much more common CHP systems are going to be in Texas by 2025. And it's going to be a consistent growth all the way up until 2025. These things are going to be used in smaller commercial industrial facilities. You're going to have 177 million megawatt hours produced compared to the current 83 million megawatt hours produced. You're going to have 200 large industrial units using these, potentially 500 plus smaller systems by 2025. Now you're also going to see natural gas consumption increase by a third from the business as usual case study to this 35% natural gas CHP goal. And this will have a total effect of consumption of 3.3 trillion cubic feet of natural gas. And if you look at this as far as from a revenue standpoint, it stands to give the state of Texas $14 billion in increased production. And this revenue, you'll see severance taxes come off of this, which will help the state. And in fact, we are since we have the best record in using these CHP units, we're a case study for other states throughout the United States to do the very same thing. And we have a huge supply of natural gas in this state, so there's a lot of good things that could come from this. Now you're also going to see carbon dioxide emissions go down. You're going to see sulfur dioxide emissions go down significantly. This will have a double-edged sword here. Not only is it going to bring revenues to Texas, it's going to have the effect of meeting the EPA's goals of reducing some of these dangerous pollutants and emissions, and some non-dangerous ones that the EPA still wants us to reduce. We're going to reduce them anyway through the means of implementing these CHP on-site distributed generation systems. Nitrogen dioxide emissions are going to go significantly down, and it's going to be a steady decrease from today until 2025. It's not just going to happen in 2025. There's going to be a steady decrease in all these pollutants over time. Water consumption will also go down. Electricity generation uses a lot of water in the generation of electricity, and through these systems you won't have that very valuable, these days very valuable natural resource of water being wasted like it is now. Also, megawatts of capacity in Texas, you're going to see a huge increase in megawatts of capacity in Texas through the use of these CHP on-site distributed generation systems. And it's going to be a huge spike, as you can see in the graph, if you compare it to business as usual and the use of these CHP systems. Okay, now this is the last thing we're going to talk about. This is a really interesting chart here. It's just showing you the different fuel sources for generating electricity in Texas. And if you look at natural gas, which is the primarily non-CHP natural gas fuel source consumption in generation facilities, this fuel source is going down each year. We're using less and less of natural gas for generating electricity. But look at the CHP systems. From 2008 to 2009, it went down a little bit, but 2010, it went up significantly. And the goal is 35%. So we're likely going to see the natural gas CHP fuel source go up each year significantly until we actually surpass the natural gas consumption in your traditional electricity facility. So this is very interesting. We're seeing signs that CHP systems are taking over in Texas, and this can only be good for Texas. As you could see from the graphs, it creates several different benefits, such as reducing emissions, pollutions, more efficient creation of electricity for businesses, and more revenue in the form of electricity generation being produced through the use of natural gas. And this will make it much easier to do that. And for whatever, in the case that natural gas becomes too expensive, if that were to ever happen, a distributed generation system can easily be retrofitted for multiple different fuel types. So this is, and that's what we talked about in the beginning of the video, the Bloom Energy Box. It's very compatible for many different types of fuel sources. So I hope this helps give you an idea of where Texas electricity generation is going, and I think it's going in a positive direction.